Today we're going to look at solving some triangles, in other words, finding angles and sides that are missing. And the key is none of these triangles are going to be right triangles. So in this situation, I'm going to look to find this value x here when I have these two angles and this given side. Now certainly I could find this missing angle by subtracting from 180, but finding this side is not quite as easy. We're just going to outline it, and then I'm going to talk about something called the law of sines that'll help us do this in one step. But if I really wanted to get this done, I'd have to probably drop an altitude. I could use a right triangle trigonometry ratio, because now I have this right triangle here on the left side, and I have a hypotenuse, and I'm looking for an opposite, so I could find sine. Once I have that, I can take and use actually sine again, because I have an opposite and a missing hypotenuse to find this angle right here. So I could probably get this done in 3 steps. Not a big deal. But let's talk about a proof that would allow me to get everything done in one shot. Let's say this is A, B, and C. And always when we write triangles, we take our sides and put them in small case letters directly across from the uppercase letter angle. So little b and little c. And let's say we're given the following. We're given the angle A, just like in the last problem, the side C, and the angle C. And we're looking to find this side A. Well, once again, we're going to kind of deal with this the same way we did in the mock-up problem prior. We're going to draw an altitude, call this H. And now I could say the sine of A is equal to H over C, but I also know the sine of C is equal to H over A. Now, doing a little bit of algebra, I can multiply C to both sides, and I get C sine A is equal to H. And multiplying A to both sides, I have A sine C is equal to H as well. Therefore, since I know both are equal to H, I can say C sine A equals A sine C. And again, with a little division property, I can say the sine of A over the side A is equal to the sine of C over C. And what that does is it now gives me one equation in which I have 1, 2, 3 of the terms, and I'm only missing 1. So I can solve for A accordingly. This is called the law of sines, and the law of sines states the following. The ratio of a side to its opposite angle and the sine of it is equal to the ratio of the other sides and the sine of their opposite angles. Likewise, I could write it as the reciprocal relationship. The sine of an angle over its opposite side is equal to the other sines of their angles and over their opposite sides. And we want to do this when you have an angle side given or a side angle given. So let's go back and do that problem that we started with. We have an angle side given, so we can use our law of sines, and I want to find x, so I'm going to put my side or my unknown on top. I say x over the sine of 55 is equal to 8 over the sine of 26. And now I can multiply by a sine of 55 to both sides, so 8 sine of 55 over sine of 26 will equal my x value, and now it's turned into a calculator problem. And we end up with an x value of 14.95 if I round to the 100th. And you want to make sure your calculator is in degree mode when you do this. So now it asks us to solve a triangle ABC given the following values. Again, it looks like we're going to have an angle, and a side. Now, once again, when we create these triangles, it doesn't matter where you put the letters for A, B, and C, but it does matter once you set those angles where you notate their sides. So opposite this angle C has to be the side of 16. And what they're asking us to do in this triangle is solve it, which means find all missing sides and all missing angles. So let's tackle the easiest part first. Let's find the missing angle. We know there's 180 degrees in a triangle, so therefore C equals 180 minus what's already been used, 120, or 60 degrees. So I'll just fill that in. And now we're left to find both B and A, those sides, so we're going to have to write two separate ratios. I'll find A first, let's say. So A over the sine of 40 is equal to 16 over the sine of 60. So just like the last problem, multiply sine of 40 to both sides. I have 16 sine 40 over the sine of 60 is going to equal A. And we end up with 11.88 for A. Moving on to side B, we take B over the sine of 80 is equal to, and I'm going to use what was given to me in the problem, anything that doesn't have rounded answers, because once I start using rounded answers to calculate a new answer and then round that, then I have multiple rounds, which isn't as accurate. So I'll take 16 again over the sine of 60, multiply by that sine of 80 again. I have 16 sine of 80 over the sine of 60 is equal to B, which gives me 18.19. And now I've solved the triangle because I've found all the missing sides and all the missing angles. Next thing we're going to do is find the area of a triangle. Now, I'm not a big fan of special equations for this, although we can use one, and I'll show you how to do it in just a sec. I know in this triangle I have 25 for my side, or for my angle, I'm sorry. I have side B of 21.1 and side C of 16.5. Now, me personally, I know that I've got 1/2 base times height gives me an area of the triangle. So really all I need in this problem is a height of the triangle. And I can get the height, h, by using a sine ratio and just say I know the sine of 25 equals h over the hypotenuse. Right? And then I have the base, which is 21, and now the height, which I'll solve for. I know h, in this case, will equal 6.76, and then the area equals 1/2 21.1 times 6.76, which is going to give me 71.32 square units. Now, again, I said, well, there's a formula we could use to get this done. And the formula is actually pretty easy. Let's say we've got a triangle given to you, and we're given a side angle side. So let's say, once again, A, B, C. And this is little c, this is little b, and this is A. Again, we'd have to drop an altitude, like so. And once we drop that altitude, we could say this is our height, and I'm given A, C, and B, and I want to basically calculate 1/2 base times height, which is what I did in the last problem. I know that the sine of A is equal to H over C, which was given to me. So C sine A equals H, and then what area equals 1/2 the base, which is B in this case, times the height, which is equivalent to C sine A. So really the area equals, let's write area because I have this other A right here, equals 1/2 BC sine A, or in other words 1/2 two sides multiplied together times the sine of the angle. And this is only if side angle side given. So we can use this formula if we want, but again I think it's just as easy to go 1/2 base times height. So now we've got a word problem, and the hard things about the word problems is you're going to have to draw the picture on your own. So you've got two cables with separate lengths that extend from the top of a television antenna, which is level to the ground, and on opposite sides of the antenna. So what the heck does that mean? It means that I've got some ground, I've got some antenna going up, and then I've got these two wires coming off the top of the antenna. One here and one here. And notice they're not the same length. So I know the longer one's 300, shorter one's 270. Longer cable makes an angle of 48 degrees with the ground. So here's the longer angle it makes with the ground is 48, and we want to find the acute angle of the shorter cable on the ground. So we basically want to find theta right here. Alright, and this is really set up nicely for a law of sines problem because I have, if you'll notice, I have two sides at an angle given. Alright, and here's the missing angle. So I could take and find the sine of theta over the opposite side, 300, is equal to the sine of 48 over 270. Again, I'm going to isolate what I need. So I have 300 sine 48 over 270. Sine theta will equal, this is a calculator problem, 826. That's rounded. Now what I'd want you to do is in your calculator leave whatever number you get by doing this multiplication and division. And now the unique thing of this problem is we aren't done yet because we're trying to find theta. So as we did in our right triangle problems, we have to find theta by taking the inverse sine of both sides of the equation. So when I do that, I pop that into my calculator and get about 55.66 degrees. That's pretty much all we've got for today. Make sure you do your Connect Ed and do your lesson summary, and we'll talk tomorrow.